lesson 2.3 on how do we add and subtract radicals. So we're going to talk obviously about adding and subtracting radicals and when we can do this, what conditions need to be in place in order to do this. So for the first example, we're not dealing with radicals. And the reason is because it's very similar to how we add and subtract just regular variables. So let's try to add and subtract these variables. So first things I'm going to do is look for like terms. When we talk about variables, like terms means they have to have the same variable and exponent. Same variable and exponent. And when we do add or subtract them, we're actually only adding and subtracting the coefficients. So we're only adding or subtracting the coefficients. That's important. Those same rules are going to be true when we add and subtract radicals. So let's start with just identifying what the like terms are here. So I have an a to the first b squared. Where else do I have an a to the first b squared? Well, that's a cubed, then negative 2b squared a. Well, that's an a to the first and a b squared. It's okay that the order is different because it's multiplication. When we multiply, the order doesn't have to be the same. Okay, so that's a pair of like terms. Now let's see if there are any other pairs of like terms. So, any other pairs of like terms? Well, a cubed, let's see. Well, that's a b squared, and then this is a negative 5a cubed, so these are like terms. Then there's a b squared, doesn't have a like term, that's okay. Okay, so now let's start to combine. So I have a to the first b squared, and there's a 1 in front. Remember, I'm really just adding and subtracting the coefficients. Keep that in mind. Okay, so when I add and subtract these coefficients, I'm really adding positive 1 with negative 2, which gives me negative 1. Negative 1 ab squared. For the a cubed, I'm doing positive 1 and negative 5. Positive 1 minus 5 is negative 4 a cubed. And then the b squared doesn't have anything to combine with. That's it. So this relates to when we add and subtract radicals. We're going to do the same thing. So in order to add and subtract radicals, they need to be like terms. And in order to be considered like terms, they need to have the same root same radicand, like exactly the same root and radicand. And they also need to have the same coefficients in the sense that if there's an x with one, there has to be an x with another, with the other one. So we'll look into that also. So we'll say the coefficients need to be able to be added or subtracted. This folder should be added or subtracted. Okay, so let's start with this first example, or example 2. Okay, so first of all, I see that the roots are the same. They're both square roots, right? But the radicands are not the same. Okay. Well, I need to ask myself, can I reduce any of these radicands, or these radicals? Well, 20y, I feel like I could probably reduce to 20, so I'm going to look into that. The 3 radical 5y, that 5y, 5 can't be broken down, y to the first can't be, so that's going to stay the same. But this guy, I'm going to try to reduce. So this is radical 20, radical y. The square root of 20. Okay, well, biggest perfect square that goes into 20 is 4. So I'm going to do square root of 4 and square root of 5. Square root of 4 is 2. And then this stays also with it. Okay, so I was able to break that down. So now if I rewrite my original problem, what it's going to look like is 3 times 5y minus 2 times 5y. Because when I broke down this, I got this. Okay? Now they have the same root and the same radicand. Now I look at the coefficients. 3 and negative 2, I can definitely add or subtract 3 and negative 2. So what I'm going to treat this like is, imagine these radical 5y's were like x's. It would be like 3x minus 2x. So I would end up with 1. But they're not x's. They're radical 5y's, right? So instead of writing x, we're going to write radical 5y. So it's going to be 1 radical 5y. The 1 is not necessary, so it's radical 5y. Okay? So an example or a common mistake that people might make, or you should put it, this is something you should put in that section of your notes, is some people might see 3x radical 5y minus 2 radical 5y and say, oh, I can combine the 3 and the negative 2. But they're not technically like terms. Even though the root and the radicand are the same, the 3x and the negative 2 can't be combined, right? If you just saw this, you wouldn't be able to combine that. So there's kind of an extra edge on this that we have to think about. Let's do another example. Cube root of 343x to the 4th minus 2x cube root of 8x. Okay, so the roots are the same, but the radicands are not. I'm going to see if I can break the first radicand down, and the second radicand, we'll see if we can do anything with that. So I'm going to just like put a little line down the middle to separate them, because I'm going to work with them separately first. So I have the cube root of 343 and the cube root of x to the 4th. Okay, well, always check if you're unsure if something is a perfect cube or perfect square, because the cube root of 343 actually is a perfect cube, and it's just 7. Cube root of x to the 4th, we're going to break down to the cube root of x cubed times the cube root of x to the 1st. Cube root of x cubed is x to the 1st, and then this x stays under. So now this just simplified to 7x cube root of x. Now I'm going to work with the right side. So I have negative 2x times cube root of 8 cube root of x. Okay, well, negative 2x just stick outside. Cube root of 8 we know is 2, because 2 times 2 times 2 is 8. So this is going to just be 2. And cube root of x to the 1st can't be simplified because the exponent is smaller than the root. So that just stays as is. All right, so now I'm going to rewrite my problem. I'm going to rewrite this original problem, substituting in the simplified things that we just came up with. So I have 7x cube root of x minus 2x. Actually, sorry, 2 times 2 is 4. So 4x cube root of x. Now let's check if we can add or subtract. Well, the roots and the radicands are the same. They're both cube root of x. And then let's see if we can combine the coefficients. 7x minus 4x. Yeah, I can definitely combine those. 7x minus 4x is 3x. And I leave the cube root of x. All right. Let's go on. So this is the last example. Last example we're going to do. I want to point something out, just like a little sidebar before we do this example to keep in mind. We've kind of talked about this, but we're going to use this idea for this specific problem. When you multiply a radical by itself, like radical 5 times radical 5, you end up just getting the radicand. The reason for this is radical 5 times radical 5 is radical 25, which is just 5. Okay, so this is kind of just like a shortcut. When you have a radical and you square it or multiply it by itself, you're just left with the radicand. So keep that in mind. All right, so I see 2 sets of parentheses. You can think of these both like binomials. There's 2 terms. Here's one term, second term. One term, second term. I'm going to multiply these together. So I'm going to take the first term and I'm going to distribute it to everything in the second set of parentheses. Now, common misconception or mistake might be that the 3 and the 2 are separate terms. But remember, terms are separated by addition or subtraction. So 3 radical 2 is one term. Keep that in mind. Okay, when I multiply 3 radical 2 and 3 radical 2, I get 9 times 2. Here's where this idea comes in. Radical 2 times itself is just 2. So that's 18. Now I'm going to multiply through radical 2 with negative 7. So I'll write that over here. 3 radical 2 times negative radical 7. Okay. Well, the 3 and the negative 1 out front will multiply together, and they'll give us negative 3. Then the radical 2 and the radical 7, those are different, but we can still multiply them together. They have the same root. So that gives us radical 14. Okay, so we have minus 3 radical 14. Now I'm going to use the second term, this positive radical 7. I'm going to distribute that. Positive radical 7 times 3 radical 2. So I'm going to write that over here. Positive radical 7 times 3 radical 2. And what that ends up giving us, well, this radical 7 just has a coefficient of 1. 1 times 3 is 3. Radical 7 times radical 2 is radical 14. So I'm going to put that here. 3 radical 14. And the last thing we're going to do is multiply radical 7 times negative radical 7. So this is why we talked about this sidebar. Radical 7 times itself is just the radicand, which is 7. The coefficients, however, do need to be multiplied. So this has a coefficient of 1, and this has a coefficient of negative 1, so it's negative 7. So then we have this minus 7 at the end. Now we're going to simplify this expression here. So I have 18, negative 3 radical 14, and positive 3 radical 14 add to 0. So this becomes 0. And then we have minus 7. 18 minus 7 is 9. That's our answer. Kind of crazy, right? How we can go from these radicals in two binomials being multiplied together to just getting a number like 9. All right, guys, that's it for now. And I will see you when we get back on Wednesday. Make sure you take notes. Make sure you write a reflection.